Hi everyone, this lesson is about inequalities. So let's begin with a few quick examples. Things like 2 is less than 5, that's an inequality. These are things that are not equal. And the symbol in the middle is read as is less than. On the other hand, we could have something like 10 is greater than negative 4. So the inequalities. Now inequalities could also involve pronumerals. We could have something like x is less than or equal to 7. So with a pronumeral, there's a range of different values that x could take, and we could symbolize that with a number line. So if I imagine a number line here, and I'll mark in the value of 7. Now, if x is less than or equal to, so being equal to 7 is included. We show that by having a solid dot on top of 7, and I might just make my pen a bit thicker. And being less than, thick red pen, being less than would be everything to the left. So any number indicated by either the red dot or the red arrow would satisfy the inequality x is less than or equal to 7. If it were a situation where we had something like, let's go 4 is, other way around, let's go less than. 4 is less than x. Now, no equals this time, so I'll put 4 on my number line. Number line extends infinitely in both directions. Once again, the red pen. This time 4 is not included. I'll use an open circle to show that 4 is the boundary, but 4 is not part of the solution set. And x is greater than means we go above, go to the right of that point. So anywhere on the red arrow, all the way down to as close as you want, but not actually at 4, is part of the solution to that inequality. So that's a quick introduction. Now let's think about what happens when we have algebraic operations on these things. So let's start with one we know is true. Let's go to 2 is less than 5. Absolutely true. Is it okay to add things to both sides? For instance, if I add 10 to both sides, I'll add 10 to get 12, I'll add 10 to get 15, and it's still true to say that 12 is less than 15. Adding is fine. What about if I subtract from both sides? What if I subtract 5? 2 take 5 is negative 3, 5 take 5 is 0. It's still true to say negative 3, so subtracting is good. Now let's multiply. We'll stick with 2 is less than 5. What about we multiply by 7? 2 sevens are 14, 5 sevens are 35. 14 is less than. Multiplying by 7 worked. Let's try dividing. 2 is less than 5. Let's divide by 2. 2 divided by 2 is 1. 5 divided by 2 is 2.5. Still true. Now here's, so all of those seem great. Adding, subtracting, multiplying, dividing. Now I'm going to throw a spanner in the works here. Let's go 2 is less than 5. Let's multiply this time by a negative number. Let's multiply by negative 3. 2 by negative 3 is negative 6. 5 by negative 3 is negative 15. Now we're on the negative side of the scale. Negative 6 is greater than negative 15. Do you notice how I've had to turn the inequality sign around when I multiplied by a negative number? Let's do the same thing with dividing. 2 is less than 5. Let's divide by the number negative 1. So 2 divided by negative 1 is negative 2, and this is negative 5. And again, I'm going to have to turn that around because negative 2 is greater than negative 5. The takeaway message from the little examples I've just given, if you are multiplying or dividing by a negative number, turn that inequality around. Everything else is fine, but if you multiply and divide by negatives, turn the inequality around. Thanks for watching. See you next time.